Hi guys, and welcome to part 2 of this first video on Unit 1 GCSE Edexcel, Hazardous Earth. So I'm making these videos, I'm going through all of the kind of key terms and processes in the units in Unit 1, and then hopefully I might get up to some units in Unit 2 for next week, those of you that are doing your mocks, either before or after Christmas. So let's get going with this one. So I'm going to be going through some of the key terms, some of the processes, etc. So the first one I've got here is Earth's layers. Now it's really important that you learn these layers because there's often 2 or 4 mark questions on describing the layers or talking about which is the thickest, etc. You might get some multiple choice questions. So please know that we've got the crust. Then underneath that we've got the lithosphere, which is the bottom of the crust, where we've got the asthenosphere, which is the sticky part that the mantle kind of sticks to and then pulls apart for the plates to move. Then we've got the upper mantle, lower mantle, the inner core, the outer core and the inner core. Please know the numbers, know the thicknesses, know some of the temperatures, etc. in case you get questions on that. So yeah, they're the tectonic plates, and then underneath what the layers of the crust are. So next we have got, let's have a look, continental and ocean crust. So do again know the difference between continental crust and ocean crust. Continental crust is thick, buoyant, light relatively, made of granite, and obviously it's what we stand on. And the ocean crust is newer in comparison because it's been made as the plates pull apart. It is dense, it's made of basalt, and it's heavy, so it gets subducted. We'll look at that in a little bit. So please know what the difference is between the two. Next, convection currents. So convection currents happen within the mantle. So this is the driving force for the plates to move. So if you get a question on this, it's probably going to be a 4 marker. So please note that the heat source is radioactive decay in the core. That heats up the mantle. That rises, cools and condenses, moves outwards, wants to fall back down again, but gets stuck to the underside of the lithosphere or the asthenosphere, sticks to that and pulls the plates apart. So that's the mechanism of plate movement. So that is our continental crust, continental currents, convection currents even. Next, plumes. So plumes are very, very strong convection currents and they happen in the mantle. Scientists don't really know why, but they're very, very strong convection currents, and they can do a couple of things. If they occur at a constructive margin, then they can push out lots and lots and lots of magma, so we'll end up with an island forming at a constructive plate margin, something like Iceland. And if they happen mid-plate, like they do in the Pacific plate, then they end up breaking through maybe a thinner bit of the crust and end up causing hotspots like Hawaii. So they're all plumes. They're very, very strong convection currents. And then finally, I think that's all with that one. So if we flip over, we have got, again, my pens get a bit weird here. So we've got subduction. Okay, I'm just going to write that again. So subduction. Okay, subduction. So subduction happens. I'm just going over that I should have done the plate boundaries first, but never mind. We'll do subduction. So subduction as a process is where the ocean crust goes beneath the continental crust. So make sure you know that when you use it, otherwise you might not get the 4 marks if you're asked about what's happening at plate margin. So plate boundaries or plate margins, okay, do lots of things as my arrows show. So plate boundaries or plate margins, same thing. Plates either, because the convection currents either pull apart, push together, or move side by side. So if they're pulling apart, it's a destructive margin, okay, and it's also called a divergent margin. Yeah, destructive, no, it's convergent, okay? It's really easy to get them confused. The way I was saying in class the other day is that C and D, the 2 C's don't go together and 2 D's don't go together. So destructive margin is converging, it's moving together. So destructive margin, you've got the continental crust, the ocean crust. The ocean gets subducted because it's heavier and dense, more dense, pushes down into the mantle, starts to melt, pressure and friction increase the heat. That causes melting of the crust, of the ocean crust, and that melts, rises, forces its way through the continental crust and explodes at the surface. We've also got earthquakes happening here, obviously, because we've got pressure and friction building up. When that pressure and friction gives, the plate moves, and that causes an earthquake, okay? Now, when the plates are moving apart, that's a constructive margin or divergent, so CD. And divergent means they're pulling apart. That leaves a gap, as it were, for the magma to well up and rise up. to the surface and form new ocean crust. And if it's a particularly strong plume, then it will form a volcano. And we'll get to the type of volcano in a minute. And then the final plate margin is a conservative margin where the two plates are moving side by side. You get pressure and friction building up. That pressure and friction eventually gives way and you get an earthquake happening. Okay, so when earthquakes happen, underneath the ground at the epicenter and at the surface it's the focus. I hope I've got that right. I might have got that the wrong way around. If I have, you know. Anyway, I always get the two mixed up. Right, so we've got Pangea is our next little thing. So Pangea, this was obviously when the Earth was new and all of the continents were together. We had Pangea, and then plate tectonics happened and it pulled all of the continents apart. So the evidence for Pangea is that the pieces fit together like a jigsaw puzzle. So South America looks like it, Africa looks like it fits in South America. We have similar rocks in the two places. We have similar fossils, etc., similar mineralogy, etc., for different bones and things like that. So that's what happens there. Right, okay. And next, bit of a weird little bit on magnetic field. Now, I'm not a physicist, as I told you in the last video. So the magnetic field, basically, you need to learn this. There might be like a 2-mark question on this, but basically the what's happening in the core creates the magnetic field, okay? And this essentially deflects radiation from us getting too much radiation. That's kind of all you need to know. That's all I know. So that's that one. So that's radiation. We've just done the different types of crust. So the different plate boundaries we're okay with. Hopefully just know what your plate boundaries are and what processes happen there, because you will get a 4 marker on that. Quite common to get either, you know, constructed, destructed or conservative margin. So make sure you know those. The only other one that I will mention is a collision zone. So that's a destructive margin where the plates are converging, and that's normally where ocean crust and ocean crust kind of hit together, so they can't be subducted, so they push up, and that will be the Himalayas. Okay, so that one's done. Right, let's have a look where we're going now. So the next one, let's see, so we've got, where are we going to go now? Volcanoes. So make sure you know your 2 different types of volcano. So volcanoes can be either shield, which happens at a constructive margin. So that's where the magma is non-viscous. It's very, very hot because it's just come out of the mantle. It takes quite a long time to cool, so it spreads out. And the volcano it's formed is normally very a large area and flatter with less steep kind of sides. So that's the characteristics, and that would be Hawaii or something like that, or something like that. And the other one is the destructive plate margin, where we have got much more explosive because it's under pressure beneath the ground. It's contaminated because it's ocean crust that's been heated up and melted. So we've got a composite volcano because it's it's composed of layers of ash and layers of lava, or a cone volcano. It's a normal, you know, your normal volcano shape, as you might think of it, as a cone shape, nice and steep. So because the lava is sticky or viscous, doesn't run as much, it's only about 900 degrees, so it solidifies quite quickly, and that is a composite volcano. So know the difference between the two. Right, okay, so that's all your physical stuff really. Right, okay, so that's your volcanoes. Next thing we're going to look at preparation and prediction. So preparation and prediction. So we can prepare for volcanoes a lot easier than we can prepare and predict earthquakes. We can't really predict earthquakes. So we can prepare for volcanic eruptions by making sure we have got lava channels in place, making sure that we have got shelters in place for volcanic bombs, making sure they've got places to go if people get their homes get destroyed, that kind of thing. It's going to be better in low-income and high-income countries than low-income countries, obviously, obvious reasons. The same thing, similar things that we looked at when we looked at hurricanes. And they can be predicted to a certain extent to evacuate people, not always, but you can see what's happening. So what's happening as magma moves from the mantle into the magma chamber, it can cause earthquakes. So small earthquakes will be felt, and that's as the magma chamber is being filled, because the lava, or the magma I should say, is pushing up and rocking the ground. We can also see as that is happening, we might have plumes of smoke, we might have small ejections of lava bombs and things like that. So we might have fumaroles where we've got got the release of sulfur dioxide, that kind of thing. So it will show us signs that it's getting ready to erupt. So that is prediction, okay? And then what you do, if you see that happening, then you move people out. If it suddenly stops, people move back in, and it could erupt, but at least you've got a bit of an idea if that's what's happening. So you can evacuate people, you can get people into their shelters, etc., that kind of thing. So that is preparation, what happens before, and then prediction, obviously trying to predict when that volcano is going to happen. The other thing you need to know is primary and secondary impacts. It's getting worse, this writing, isn't it? So primary and secondary impacts. Primary means what happens straight away. So destruction, lava everywhere, all over the fields and everything, people's houses being destroyed. And secondary is what's happened afterwards. So if you have got people being evacuated and it's winter time, then people might get pneumonia. If it's summertime, you know, they might get diseases because there's a lack of clean water. So that would be secondary impact. So make sure you know primary and secondary impacts. And then make sure you know these two words, relief. You can't even read it, but I'm telling you it. Relief and aid. So relief means what happens later. What relief did they get means what help did they get. So poorer countries will often get more relief, obviously, or aid from foreign countries, and richer countries may not get as much, although like relief could also be like technical help to get people out of buildings, lifting equipment, sniffer dogs, that kind of stuff. So it can happen in both countries, but it's more likely to happen in a poorer country than a rich country. And then finally, we have got management and stuff like that. So first of all, let's look at earthquakes. So like I said before, earthquakes happen because of build-up pressure. So when two plates are pushing towards each other or pushing against each other, they snag. There's not a clear boundary like there might be between two tables. It's uneven, so they're pushing in opposite directions or pushing together, in which case there's a big build-up of pressure. When that pressure is released, when the plates move past each other, that release of pressure causes an earthquake, obviously. And focus is beneath the ground. I don't know what I said before. Focus is beneath the ground, and the shallow focus is worse than deep focus, because deep focus means that the earthquake occurs right within the crust, and then those waves, those P waves that kind of move outwards, it's like when you drop a stone into a pond. The biggest ripples will be round where you've dropped the stone in, and then as you move out from that stone being dropped in, the ripples will get less and less. And that's what happens with an earthquake. The closer you are to the focus and then the epicenter, which is above the focus on the ground, the closer you are to that, the stronger those waves are, so the more destruction is going to happen. And then the further away you are from that epicenter, the less destruction. So the more shallow that focus is, it's going to have a bigger impact, maybe. Okay, so that is that. Now, tsunami. Tsunami means harbour wave. It means harbour wave in Japanese. That's what tsunami means. Because you can only really see it when it gets to the coastline. So tsunamis are formed when you've got two plates underneath the sea, like you might have in the Indian Ocean, when the Indian Ocean happened all that time ago in 2004, I think it was, wasn't it? I think it was, yeah. So the two plates are pushing under each other, they're being pushed down, and then suddenly one of them gives way and springs back, rebounds, we can use that term, and it displaces that water. So remember, the difference between a wave and a tsunami is that a wave is where we've got the ocean and the wind just moves the top of the ocean, so we just get these waves forming. So that's waves. They can be quite big, obviously, if it's a hurricane. So what happens with a tsunami is that the displacement of that water happens through the whole body. So the wave, that energy wave from the pinging up or the rebound of the plate, pushes the entire body of water. Now, when you've got a really deep ocean, you're going to see a metre or so above the water, so you can't really notice it. As it gets closer to the coastline, it will get more shallow, shallower. So this will be the ocean, and this is the base of the ocean, nice and deep, so we won't get much of a movement. But as it moves towards the shore, it's more shallow, so all of that water then pushed on land, and that's when the wave lifts up, and we can see like a 10-metre high wave or whatever it is, and that will hit land, and all of that water. So it's not just the top of the water that's hitting you, it's the entire body of water which is going to hit you, and then it's going to go back out again. So as it hits, it's going to cause all that destruction. Then as it goes back out again, it's going to cause even more destruction as it takes all that stuff that it's destroyed back out to sea. So very, very destructive, obviously. And then you've got the 2011 Japanese earthquake and the Haiti earthquake in the book as you do case studies. So Japan and Haiti impacts. So Haiti, sorry, Japan, let's start with Japan, the high-income country. So the earthquake itself didn't kill that many people. Only killed, I mean, maybe like 6 to 9 or 12 or something like that. Different sources give you different figures, because most things in Japan are earthquake proof, all right? However, what killed most of the people were the secondary impacts, which is the tsunami, because they didn't think it was going to happen, so the seawall was breached. And also, a lot of the buildings were built to withstand the earthquake, so they're made of light timber and stuff like that. And then the tsunami wave hit and killed over 20,000 people. I think the book says 15, but you can get away with saying about 20, because I think in the end that's what it killed. So the earthquake didn't kill many people, but the secondary impacts were very great there, because Japan's got a lot of earthquake-proof buildings. And in Port-au-Prince in Haiti, in 2010, massive amount of destruction there. Haiti, one of the poorest countries in the world, unfortunately. Magnitude 7, the other magnitude was a lot higher in Japan, was 9. But it's a lot more developed Japan. So caused all kinds of issues. So the buildings weren't built properly. There was a lack of structure to the buildings, structural integrity of the buildings. The foundations weren't very deep. They weren't prepared. It was very high density buildings in Port-au-Prince, in the capital. It was just awful. So 250,000 people, over 250,000 people died. And then obviously the secondary impacts were that the aid workers came and they'd been to Africa and they brought cholera with them. So I think there was another 250,000 people died as secondary impacts. So huge, huge issues there. So much, much worse impacts in the LIC than the HIC. And finally, management in LICs and HICs. So management in high-income countries, really good in Japan. Earthquake-proof buildings. You've got the diagram in the textbook, which I'll just show you. This one here, showing all of the ways that we've got earthquake-proof buildings. So deep foundations and cross bracing, and the little thing, that little ball at the top, which is the damper that acts like a pendulum to stop it swaying. Shock absorbers, shatterproof glass, all that kind of thing. And then in the countryside or in the other places in Japan, they're made of lightweight building. The buildings are made of lightweight material, so they don't crash and squash you. And then in the LICs, we have got management here, because we've got quite lightweight buildings. Yet again, you've got lightweight buildings here, so similar stuff that I've just talked about here. You've got they're on stilts, so gives it a bit of stability. They've got a little wood kind of bends and moves. The roofs are made of lightweight material, so they don't kind of crush you. Bamboo is used because it's light, etc. So there are quite a lot of ways that you can make your buildings more earthquake proof. Okay, but overall, obviously, the impacts are going to be greater. They're going to be greater in cities than it is in towns, because the density of the buildings, etc., in poorer countries. Yeah, and that's it really. So that is the end, I think, of this unit. So you've got 2 videos here on hazardous earth. Please check out the other one if you haven't before. It's on climate change and hurricanes. And if you haven't liked and subscribed, please do. And then look out for the next video, which is going to be on the next bit of the unit, which is development dynamics. So see you soon.